Bismillahirrahmanirrahim. Assalamu alaikum students. Our today's lecture is about pressure sensors. Pressure sensors, the measurement and control of fluid, you can say liquid, air, and gas. The pressure has to be one of the most common in all the process industries because of the great variety of conditions, ranges, and materials for which pressure must be measured. There are many different types of pressure sensor designs. In the following paragraphs, we can say that in this study, the basic concept of pressures are presented and a brief description is discussed in this lectures for pressure sensors. And we will also see that the pressure measurement is often accomplished by different converging techniques of pressure information to some intermediate form such as displacement, which is then measured by a sensor to determine the pressure. Pressure is basics about the basics of pressure. We can say that pressure is a simply a force per unit area that a fluid exerts on its surroundings. That we can say we can define the pressure as force per unit area, and this magnitude, or we can say this quantity pressure, can be measured in different units, such as we can say that pounds per square unit, inches of water, millimeters of mercury, pascals. Or Pascal is also equal to Newton per meter square or bar. Until the introduction of SI standard international units, the bar was quite common to measure pressure as force per unit area. And then in SI units, Pascal was introduced, which was equal to Newton per meter square. And then we can say the different types of the the pressure which were we will be used, which were we have to deal in industry, that should be in the form of liquids or in the form of gaseous pressure. So we can say that if it is a gas, then the pressure of the gas is the force per unit area that the gas exerts on the walls of the container that holds it. If the fluid is a liquid, then pressure is the force per unit area that the liquid exerts on the container in which it is contained. Obviously, the pressure of a gas will be uniform on all the walls that must enclose the gas completely. In a liquid, the pressure will vary, being greatest on the bottom of the vessel and zero on the top of the surface, which need not to be enclosed. You can see that mostly the liquids present in a vessel or container, they exert pressure on the bottom and the surrounding walls, but the top, or we can say top of the vessel or container, has a zero pressure on it. Now we can say that different types of pressure, that we can say static pressure, dynamic pressure. The in the atmosphere, we can say that at any point the static pressure is exerted equally in all directions. Static pressure is the result of the weight of all the air molecules above that point passing down. For example, we can say that the fluid that is not moving in space, that is not being pumped through pipes or flowing through a channel, the pressure in cases where no motion is occurring is referred to as a static pressure. When there is no motion to the object, that object is facing a static pressure. Static pressure does not involve any relative movement of the air. And in this figure, you can see that if a hand is present in the air, it has a static pressure of air on all from all the directions. Like the capsule, to measure static pressure, this is the capsule on which the pressure of air and low static pressure at altitudes, static vent is present, and capsule to be measured static pressure, and it is in the free atmosphere. Then air molecules exerted pressure at all the points pressing it downwards. For example, here is an example to measure the pressure. We can say the liquid in a container has a total weight of 250 pounds. The container has a 3.0 feet square base. What is the pressure in pounds per square inch? We have to find the value of the pressure in pounds per square inch. We can say that PSI units we have to measure the pressure. We know that a feet has a 12 inches equal a feet 1 feet is equal to 12 inches, and the feet square will be equal to 12 cross 12 will be equal to 144 inches, and this is a 3 feet square. So we can say that if we have to calculate the exact value, okay, we will use annotations, then 1 feet is equal to 12 inches. Okay, 1 feet square will be equal to 12 cross 12, which will be equal to 144, as we know that. And as we know that the liquid in a container has total weight of 250 pounds, so we have to divide 250 by the area 3 feet square, and which will be equal to, we can say that we have to find out the pressure in psi, then of the value of pressure P will be equal to 250 divided by 3 cross 144. So which will be equal in units of P S I, and if we calculate this will be equal to the value of 0.58 psi, will be equal to 0.58 psi. So this is the way that we can calculate the pressure of the liquid in a container according to the area of the base. So now we move on the next slide. In next slide, the units of pressure are discussed, and we have to clear the page first. We can measure pressure in different units, as we can say that pounds per square feet PSF or pound per square inch PSI, atmospheres ATM, pascals, Newton per meter square or kilopascal, which is equal to 1000 pascal, torr, which is equal to 1 millimeter mercury, 1 mm, bar, which is equal to 1.013 atmosphere and is equal to 100 kilopascals. And before the units of pressure introduced internationally, most of the things which we use, units we use to measure the value of pressure, we can say that we mostly use in bars, which is equal to 1.03 atmosphere and equal to 100 kilopascals. Okay, the different things we have discussed. The units, different units are present to measure the pressure, and the unit of Pascal is described from SI system of units, which is equal to Newton per meter square, and usually 1 Pascal is equal to 1 Newton per meter square. As we have seen that it is not very convenient unit and is often used in conjunction with the SI standard prefixes. That, for example, we can say that kilopascals or megapascals, and you will see that in combination with Newton per centimeter square use. But use of these combinations should be avoided in favor of Pascal with the appropriate prefix. And in different English units, we can say that one different quantities have been made. Like, for example, this example is given. What pressure in Pascal corresponds to 15 pounds per square inches? That we have to find out the value of that, how much. And when we have different tables in different books are given to measure these quantities according to the rules, and from we know that 1 Pascal is equal to 6.895 kilopascal per pound square per inches per pound per square inches. Where I will try to write down this quantity here by using the annotations. One ESI is equal to 6.895 kilopascals. You can say that kilopascals. And by using this thing, we have to multiply the value of 15 psi with 6.895, and it will give us the value of the pressure in kilopascals, which will be equal to 102.9 kilopascals when we multiply this quantity with 15. Then answer will be equal to 102.9 kilopascals. .9 kilopascals. Hydrostatic pressure is the pressure in liquid we have to measure. The pressure increases as the depth in a liquid increases. This increase is due to the weight of the fluid above the measurement point. that at which point we have to measure the pressure. uh, that pressure is dependent on the depth of the liquid. As the depth of liquid increases, the pressure value quantity is also increases according to the depth of the liquid. And the pressure in this case is given by P is equal to gamma into H, and where P is the pressure in pounds per unit area or pascals, we can say, and gamma is equal to the specific weight, which is pound per feet cube in English units or Newton per meter cube in SI units. Gamma is the specific weight of the liquid oxygen, and H is the distance from the surface in compatible units. We can say in feet, inches, centimeter, meters, and so on. In different units, we can find out or measure the distance. And we have to keep in mind that H is the distance from the surface of the liquid to the bottom of the vessel. And from this, we can find out the value of the pressure in hydrostatic pressure in pascals. Uh, okay, from this animation. Okay, in some basics of pressure, the dynamic pressure, we will consider that if a fluid is in motion, that if anything we have to find pressure on that thing. If that quantity is in motion, the pressure that it exerts on its surface on its surroundings depends on the motion of that, how fast or how slowly it is moving. Thus, if we measure the pressure of water in a hose with a nozzle closed, we may find a pressure of say 40 pound per square inch. Note force per unit area is the basic definition of the pressure. If nozzle is opened, if nozzle is closed, we found that a pressure of 40 pound per square inch, and if nozzle is open, the pressure in the hose will drop to a different values. We can say that 30 pound per square inch. For this reason, a thorough description of the pressure must note the circumstances under which it is measured. Pressure can depend on flow, compressibility of the fluid, external forces, and numerous other factors which we should consider when we are measuring the value of the pressure. So, when we are measuring the value of pressure, when that quantity on which we have to measure the pressure, if that quantity or liquid or gas is in liquid or any physical quantity or hand is in motion, then the pressure will be, we can say that will be a dynamic pressure is due to the relative movement of that object. Dynamic pressure occurs when a body is moving through the air or the air is flowing past the body. Dynamic pressure is dependent on two basic factors which we have to consider, which is the speed of the body relative to the flow stream. The faster the car moves or stronger the wind blows, the stronger the dynamic pressure that you feel on your hand. If and this is because of the greater number of air molecules that impact upon it per second. And we know that pressure is force per unit area. And second fact which we have to consider is the density of the air. The dynamic pressure depends also on the density of the air. If the flow rate was the same and the air was less dense, then there would be less force and consequently a lower dynamic pressure. And if the air density of the air is thick, then the pressure will be dynamic pressure will consequently will be increase in value. So we have to consider these two facts, that on which the pressure we are measuring depends that how dense the air is and the speed of the body relative to the flow stream. Okay, next, absolute and gauge pressure. The absolute pressure is measured relative to the absolute zero pressure, the pressure that would occur at absolute vacuum space. All the calculations involving the gas laws requires pressure and temperature to be in absolute units when we are measuring the quantity of absolute temperature. In many cases, the absolute temperature is not the quantity of major interest in describing the pressure. So, the atmosphere of gas that surrounds the Earth exerts a pressure because of its weight at the surface of Earth of approximately 14.7 per square inch pound per square inches psi unit, which defines the atmosphere unit. If we find out that one atmosphere unit, 1 atm is equal to 14.7 psi. If a closed vessel at the Earth's surface contained a gas at an absolute pressure of 14.7 psi, then there would be no net pressure on the walls of the container because the atmospheric gas exerts the same pressure from the outer side of the that container, or we can say the vessel, outer side from the outside of the walls. In cases like this, it is more appropriate to describe pressure in a relative sense, that is compared to atmospheric pressure. This is called the gauge pressure, and this gauge pressure we can define in other ways, that pressure is often used to measure the pressure difference between a system and the surrounding atmosphere. So this pressure is often called gauge pressure and can be expressed as the gauge pressure. We have denoted that in with the symbol of G. Pg is equal to Ps minus P atmospheric. Ps is the surrounding pressure and P atm is the atmospheric pressure. Pg gauge pressure, system pressure or surrounding pressure or atmospheric pressure. Due to varying atmospheric pressure, gauge pressure measurement is not precise while absolute pressure is always definite, because the surrounding pressure is varies as according to the pressure of the air. Sometimes it blows fast, or sometimes it is thick, or is its density is also varying and its speed is also varying. So these quantities and the value of the gauge pressure is not precise, and it varies according to different conditions, and in different environments has different values, we can say that. And when we are measuring gauge pressure, we have to insert a symbol of G with that, which will specify it's about that it is a gauge pressure. That, for example, if we measure the gauge pressure in pound per square inch psi units, then we will insert a G sign with that psi G, which will show that it is a gauge pressure, which we are measuring according to the atmospheric pressures. Okay, now there is another example. We can say that a tank holds water with a depth of 7.0 feet. What is the pressure at the tank's bottom in pounds per square inches and Pascal? Density is equal to 10 cube kilogram, 10 is about 3 kilogram per meter cube. This is the solution. We can see that pressure in Pascal directly by converting 7.0 feet into meters. We can easily convert the feet into meters, which will be equal to approximately, and that 0.3048 meter per feet is equal to, will be equal to 2.1 meters. 7 feet will be equal to 2.1 meters. From different tables we can calculate this, and the value of P then will be equal to 10 is about 3 kilogram per meter cube into 9.8 meter per second square and multiplied by 2.1 meters. And we can say that tank holds the water with depth. We are multiplying 9.8 meter per second square because it's the this can say that gravity, which is vertically acting on any most of the surfaces, with the value of G, and 2.1 meter is the depth of the uh, water. And by calculating it, we can say that the value of pressure will be equal to 21 kilo Pascal. And if we have to find out or measure the uh, pressure in PSI units, is in pound per square inches, then we only will multiply the value in different units, or we can convert the kilopascals is equal to into PSI units, as we know that the approximately 1 PSI is equal to the 6.895 kilopascal, which we use in the previous example. So the value will be equal to approximately 3 point some psi is will be converted, and we as we easily know that 1 psi is equal to 6.985 kilopascals. So as we know that 1 psi is equal to 6.895 kilopascal. So if we divide this value of 21 kilopascal with 6.895, that will be equal to approximately 3 uh, pounds per square inches in the value. So easily we can convert the values from kilopascal to pounds per square inches. Okay, most of the time we have measures or we design different pressure sensors for the measurement of pressure higher than 1 atmosphere. Pressure differs from those employed for pressures less than 1 atmosphere. But we have to consider the quantities or sensors which are measuring more than 1 atmosphere pressure. The basic operating principles of many types of pressure sensors used for the higher pressures are considered in this course of industrial electronics. And we have to be aware that this is not a rigid separation, because we find many of the principles employed in lower pressure measurements. Most of the pressure sensors used in the process industry, we can say, results in the transduction of the pressure information into a physical displacement methods. And according to the basic principle, mostly different techniques are used for measurement of pressure. Measurement of pressure requires techniques for producing, we can say that reducing the displacement, and means for converting such displacement into a proportional electrical signal. And then that electrical signal, according to, and we have different calibrated measurement tools which will convert the that displacement into the pressure we are going to measure. This is actually, we can say that, however, in very low pressure region is not possible, where many purely electronic means of pressure measurement may be used. We have to use different electronic sensors to measure the low quantity of pressure, for example, less than 1 atmosphere pressure. For example, different transducers and elements have been used, Borden tube, helix and spiral tubes, spring and bellows, and diaphragm, manometer, single and double inverted bells. And these are the different pressure transducers which we use in the measurement of pressure quantities. Uh, Now, according to manometers, are good examples of pressure measuring instruments. These are U-tube manometers consist of U-shaped glass tubes which are partially filled with a liquid, and this liquid is used to measure the different atmospheric pressures and air pressures, vacuum pressures, etc. We can say that when there are equal pressures on both sides, the liquid will be leveled, as we can say that in the first part. When the pressure is different on both sides, correspond to 0 point on the scale. 0 point will be when the both sides of the you have equal quantity of pressure. But when the pressure differs, the 0 point will be moved from above, and that height will be converted into the value of pressure, which we can easily convert by using the given this formula, which is equal to PR minus PL is equal to gamma into difference in the height of the liquid in the columns. This is the liquid difference of the liquid in the height of the column, where gamma is specific weight of the liquid in the manometer. We can say this is the weight of the liquid which is present in this U-shaped tube. Weight is presented in terms of gamma symbols. The liquid in a well manometer has a specific weight of 40 pounds per feet cube. How far will the liquid rise in the smaller leg if the pressure in the larger leg is 1.5 pounds per feet square higher than in the smaller leg? In this example, we have to measure the value of the height that how much it is higher than the smaller leg. The pressure is given in 1.5 pound per feet square, and we know that the formula T is equal to H cross gamma, and from that formula we can find out the value of the height. H is equal, will be equal to P over gamma, and the value of gamma is given in specific height 40 pound per feet cube, and the pressure is 1.5 feet pound uh, per feet square. So we can find the height from this formula, and we can annotate the given thing by using annotation. I will let you know that how we will solve this example. You know that E is equal to gamma cross H, where H is that height which is required for us. Then so we can say that H will be equal to P over gamma, and the value of P is equal to 1.5 pound per feet square divided by 40. Okay, the feet square, feet cube, and pound will be cancelled with each other, and this will be equal in the form of feet. 1.5 feet, we will convert it into inches so we can have some significant answer. So it will be approximately equal to, when we will convert it into inches, equal to 0.45 5 inches. So this is the value of the height in the that how much difference is from the higher and lower, the smaller leg. This is the difference we have calculated here. And now we will see another example on the next page. The liquid in a manometer has a density of 850 kilogram per meter cube. What will be the difference in the liquid levels in the manometer tube if the differential pressure between the tube is 5.2 kilopascal? And we will use the same formula, and what will be the difference, and we have to find out the value of H again. By using this formula we can easily find out the values, and we know that here the differential pressure is given in kilopascals, 5.2 kilopascals, and the density is also in 850 kilogram per meter cubes. So we can use the Pascal. We can convert as Pascal is also equal to Newton per meter square, and kilogram meter cube can be equal to Newton. So we have to use some different conversions in the units to find out that thing exactly. Okay. Now from this annotation, we will erase this part. Okay. We know that as P over gamma will be equal to 5.2 kilopascals. So by putting the values and rearranging the units, we know that we have to convert these units, and we have to find out the difference h in some reasonable units. So we converted the uh, Newton per meter square by 9.8 meter cube. And so we use this thing, and by calculating these values, the answer will be in centimeters, as we know that this meter square and meter cube will be cancelled with each other, and kilogram per meter cube and newtons and pascals are also equal to Newton per meter square. And by converting these units, the differential pressure between the tubes and the difference will be equal to approximately 60.2 centimeters. So this will be the best thing we have seen here. And next, okay, let's see what's in the next slide. These are the C border tubes. Okay, we will see these C border tubes in the next lecture. So you will keep on practicing these questions of finding out the pressure and distance and the height difference between manometers and different other questions from the books mentioned. So, inshallah, we will see about bottom two in the our next lecture. Take care, students. Allah Hafiz.